All right, this is going on page 70 when we're done. So in this unit so far, we've worked with exponential functions and logs and using their properties. We've done a lot of equivalent representations. That phrasing comes up in everything that we do. So now we're going to use these properties to solve equations and inequalities. We're starting with just equations today. Okay, so these properties right here, we've already reviewed all of them. The exponential ones we did last semester. We talked about them again, and then these log properties specifically we did yesterday. But if we look at these exponents, remember the product property, you've got two terms with the same base, and so you add the exponents. If you have a power to a power like this, that's when you multiply the exponents. And I'm pretty sure we all do understand the difference, but when we're not paying attention, sometimes we mess things up with those. So just be careful. And then your negative exponent, if you have a negative exponent, the negative makes it the reciprocal, and then whatever the exponent is just that property there, okay? To go along with this, one thing that we need to also know is that b to the 0 would equal what? 1, okay? B to the 0, anything to the 0 power is 1, all right? That is important. Now when we look at our properties of logs, product property that we talked about yesterday, if you have the log of a product, then you can split that into two logs that are being added. If I have a quotient, then I can split it into two logs that are being subtracted. And then, of course, our power property, all right? To connect this right here with a log property, if I rewrote that as a log, the base of the exponent is b, so this would be log base b, and then I go around the equal sign of 1. What would log base b of 1 have to equal? 0. Okay? So whatever the base is of the log of anything, any base of 1 is going to be 0. And that is because one of the things that you really should have in your little brains is pictures of the parent functions. This is your parent function of an exponential, right? This is your parent function of a log. They are reflections of each other in the line y equals x. And since here the input is 0 and my output is 1, that's why your y-intercept is 1. Here my input is 1 and my output is 0, that's why your x-intercept is 1. Okay? Those little things, being able to draw that and know where the 1 is and know that you have asymptotes, can be hugely helpful in solving things. Okay, we all good so far? All right, so if log base b of 1 is 0, then what is the natural log of 1? 0, because that's just a log base e, right? Another important thing to know is that if I have log base b of b, so think about that. If I rewrote this as an exponential, that'd be b to some power gives me b. So what would it have to be? 1, exactly. Which means that the natural log of e is 1. Okay? Because on some of these that are non-calculator, it's fine to stop and have logs in your answer because you cannot calculate them, but some of them we can calculate. And especially if the base and the argument match, then they're just going to become 1, and it just makes simplifying everything very easy. But it's not easy if you don't recognize how that works. We good so far? All right. And then converting, that's the last thing on this little table, which we literally just talked about up there. But the base of the exponential and the base of the log are going to be the same. And then you take, so this would be log base b of a equals c. You go around the equal sign. Or it would be b to the c power equals a. So just remember, the base is the base, and then you go around the equal sign, whichever direction you got to go. We all good so far? All right. So we're starting out pretty basic today. We're looking at equations. Before we have evaluated, we've rewritten, we've done other things like this, but we're actually going to solve equations, but with only one log or exponential function. So only one log or exponential. We'll look at what happens if we have more than one and some other things going on, right? So here's our little steps to solving it. The first thing we do, and the first word and the first step is the most important, and the one that if we don't actually do this, this is where we start making up math and things get bad, is to isolate the exponential or log, depending on which one we're doing. When we go through these, I'll make sure you know exactly what that means, but you got to make sure it's really isolated. Kind of like when you simplify things, you got to make sure it's really simplified all the way. And then after you've isolated it, then you're going to convert the equation to the alternate form. If it's an exponential, you make it a log. If it's a log, you make it an exponential. Then step 3 says solving for the variable, but it should say solve for the variable. And it does say if necessary, because sometimes when you do step 2, you already have x equals whatever, and then you're just done. You don't have to solve because it's solved. And then simplify and or round your answer as directed. We're not rounding anything right now because we're doing all this by hand, but we do have to make sure everything is simplified all the way. Okay, any questions at all? All right, let me make sure these make sense to you. Let's flip this over. Okay, so here is my well, this is an exponential equation, but that's my exponential term. I got to isolate him, which means I got to get him by himself. So I need to move that 2 legally. Don't make up stuff. It's the same algebra rules you've been doing forever. So what am I going to do with that 2? Add it. So this is 4 to the x equals 9. That is now isolated. There's nothing added, subtracted, multiplied, or divided with that exponential term. So now I can rewrite it. This would become log base what? 4 of 9 equals x. There you go. It's solved. We did step 2, which was convert, and it is solved, and we don't have to simplify, so there you go. Okay? Everybody good so far? All right. So then here, we're going to isolate this term. So I'm going to move that 5. So I get 2 to the x plus 3 equals 21. Now, last period, somebody asked me a question at the end. It was a good question, and I wish sometimes I wish I had these questions asked earlier in the day. He said when he first saw that, he thought about how we have split them up in the past, like how 2 to the x plus 3 is also 2 to the x times 2 to the third. Remember when we split them up that way? Okay, and that was to get them in different forms. Because remember, I'm multiplying 2 terms with the same base. I add my exponents, right? Which means I can also go the other way. And then I can make that 8 times 2 to the x. And that totally is fine. We really kind of, I've only seen you be expected to do it that way if they're asking you to change it from a horizontal translation to a vertical dilation. You're kind of told to do that. From what I have seen, if you were asked to solve something like this and it was multiple choice, the answer choice probably wouldn't match that method. I'm not saying it couldn't, because it could. It's probably going to match this method. That's what I've seen more. So, but that was a good question, and good that he recognized that, because we can't lose sight of the fact that that is a thing we need to be able to do. All right. So anyway, we have this now. Now I can change this to a log. This would be log base what? 2 of 21 equals x plus 3. We all good? All right, so now I don't have x. Now that I've isolated, rewritten it, now I need to isolate x, which means I subtract 3. So I get log base 2 of 21 minus 3 equals x. Do you think I can make that log base 2 of 18? No, because the log base 2 of 21, this in itself, that first term, is some number. Whatever that value is, do you have any concept of what that number is? No, I don't either. I could think about it a little bit and maybe guess, but it doesn't matter. I would take the log and then I would subtract 3. So you cannot subtract the 21 and the 3. Okay, we okay with that? And I do feel like for the most part we get that too, but then still, even when you get it, sometimes y'all do weird things. And then you go back and you look and you go, why did I do that? And I can't answer that question. I don't know. But okay, so that's as far as I can get on this. But if I had done all this, and this, instead of this being a 21, if that was log base 2 of 2, what would this first term become? Log base 2 of 2 would be 1. So then out of 1 minus 3, and my answer would be negative 2. Like I could go farther if I had that, but I can't do anything else with it like it is. Okay, everybody okay with all that? Okay. All right, so now let's look at this one. We got an E in here, but that's okay. We're going to move that 3, so I'm going to get a negative 10 equals -4 times e to the x, right? Now, even though I have one term on the right-hand side, my exponential is not isolated because I have a 4 being multiplied right there, okay? So I need to move that. I can't rewrite anything yet. I need to move that legally, which would mean I do what? Division. So I will get -10 divided by -4 equals e to the x. So that can become 5/2. All right. Now it's 100% isolated. Just the base and the exponent. Now I can rewrite it. What's the base of the log? Yeah, the base is e, which means I write it as a, I heard it, natural log. Good. So this will be the natural log of what? 5/2 equals x. Even though the base is e, you don't see the e when you write it. Any questions at all about where anything came from? Well, good. And you can't do anything else. All right. Let's look at some logs. I've got this log right here. I need to isolate it. So the first thing I'm going to do is subtract 4. So that gives me 2 times log base 3 of x plus 3 equals 6. Now I have 2 options here, okay? And you get to decide on which one you think is the best. 2 is being multiplied here, so I could divide both sides by 2 because I got to get rid of the 2, right? I could divide it. We all agree with that? What's my other option? Make it an exponent. You have that power rule where this could become the exponent up there, right? Okay, and so that would give me log base 3 of x plus 3 squared, okay, because that's my power property. And in some cases, that might be the better way to do it. And it's a matter of opinion, but I think here, if I'm going to have to solve for x, I would rather not square this if I didn't have to. Would y'all agree with that? So instead of making it the exponent, which I could, which if you're following steps like in a question, that is a legal step, but division is also a legal step. So I'm just going to divide and get log base 3 of x plus 3 equals 3. Okay, everybody good with all that? Now the log is isolated. I just have the log and its argument, and that's it. So I'm going to change it to an exponential. What would the base be? 3. Okay, 3 to the 3rd power, right, equals x plus 3. Oops. Make it like an x plus 3. There you go. What? How did I get that? To rewrite it, the base of the log is the base of the exponent, and then you go around the equal sign. You can go either direction, yeah. Oh, yeah. We're changing it from a log to an exponential, yes. Not 3 to the cube root. No. 3 cubed. What's 3 cubed? Heard a lot of numbers. There you go. 27. Equals x plus 3. And then that just means that x is equal to 24. Okay. Any questions at all? All right, then you do B. Now be nice, children. That's where I had my math on. I was like, wait, 6 divided by 6. Okay, do y'all all agree with my first step here? All I did was subtract 2. We all on board? All right, now I can rewrite it, yes? Well, if you divided by 2 and got the same answer, then you did it wrong. Well, no. Hang on. Everybody pause here because this is a mistake that happens. Everybody listen. If you got 2, no, you didn't get lucky. You're 100% wrong on everything you just did. 2x minus 1 equals 4. If you are going to divide both sides by 2, this is what you would get. 1 plus 1/2 times log base 5 of 2x minus 1 equals 2. Because you would have to divide every single term by 2. Does that make sense? And that does not make that 2 go away, because the opposite of addition is not multiplication or division. You just made it even harder for yourself. Okay? Wrong math, but I just wanted to make sure you understood. It's not just wrong because you divided. It's wrong because you divided wrong too. Okay? Just making. Well, that's. But listen, y'all listen. If this was a free response question, he's really proud of himself, and I've been there too, honey. I'm not calling you out. That he got lucky because he did the wrong math and got the right answer. You know how many points that would get you on the AP exam? 0. Okay? Luck don't work like that. On a multiple choice, yes, because nobody would know. But if your work does not match your answer, then it's a no-go still. Okay? All right, so, but we have to subtract because that's being added. We good with that? Now I rewrite it. This becomes 5, whoops. This becomes 5 squared equals 2x minus 1. What do I do with that 1? Oh, I'm sorry. This becomes 25 equals 2x minus 1. So I get, bless you, 26 equals 2x, and x equals 13. Okay. Any questions at all? Okay, now this last one here, it's got a natural log and a fraction, so it must be the hardest thing you've ever had to do, right? What would the first step be? Okay, 100%. But I'm going to use this as a time to talk about something else real quick. Because in this situation, whether it's a log or not, it could be any kind of function, not just a log. I could rewrite this before I worry about solving anything as 1/5 times the natural log of 2 minus x equals 1. Okay? Do you see how that is the same thing? Okay? That is important that you see that that is the same thing. Now, do I need to do that for this question? No. Would I suggest doing it? No. But I want you to see that because sometimes things are in this. Let's say that this wasn't an equation. It was an expression and I didn't have the equals 1. I can't multiply both sides by 5 because they're not two sides, right? But I might need to make it a fraction so I could do something else with it. You with me on that? So sometimes y'all don't see that those are the same thing, either going from here to here or going from here to here to make it into one fraction. So I just want you to recognize that every time we can, all right? But even if you did that step, which is, again, totally unnecessary for this particular question, I still am going to do the first step as multiplying by 5. So that'll give me the natural log of 2x, oh, not 2x, oh my gosh, 2 minus x equals 5. Okay. Now, is my log isolated? No. Yes. Now I can rewrite it. What's the base of my exponential? E. So it'd be e to what? The 5th equals 2 minus x. Now I would really rather that be x minus 2. Can I just flip them around? No, I can't if I want to be wrong, right? But I just can't do that. All right, so I'm going to subtract 2, so I get e to the 5th minus 2 equals negative x. Divide by negative 1, so I get negative e to the 5th plus 2 equals x. Okay. And if you had 2 minus e to the 5th, that'd be totally fine too. Any questions at all? So these are very simple, so you got to make sure that you understand these 100% before I put more stuff in there. Any questions at all? Awesome.